Hi, my name is Josh Davis, and this is my final project for ME 305. One of the most common problems you'll face as a woodworker is making sure that your material is actually flat, straight, and level. Oftentimes, when you buy wood from a big box store, it comes with bends or curves, and the average hobbyist woodworker doesn't have the tools or ability to remove all of those defects. So my goal was to make a machine that would take a standard router and allow any woodworker to remove those defects. The machine is controlled by an Arduino that turns two stepper motors that either raise or lower the platform to whatever height is needed. In order to ensure precise movement, a magnetic encoder is used to measure the rotational position of the shaft. The way it works is a magnet is placed at the base of the shaft here. As it rotates, it causes a change in the magnetic field that is picked up by the sensor here. This sensor is so precise it is able to pick up 4,000 different positions in a single rotation. The Arduino then calculates how many revolutions are needed to get to the desired height. Alright, let's talk about all the different ways you can move this thing. First off, you have raise and lower. This is your rough manual movement to get the platform in the general area that you want to go. After that, you'll hit home to set your new 0 position, and then one of the things you can do is input a specific height that you would like to go to, for instance 0.1234 inches, and it'll move you there using PID controls. Your other option is to use the incremental movement. You can select 1/16 up to 3/8 of an inch to move the platform up and down in that set amount. The Arduino will keep track of how far you've gone since the last time you set a new home. It'll print this out to the LCD as current height as well as to the remote on your phone. There is also a step counter included on the phone to help you keep track of how many times you've pressed up or down with that increment. There are two kinds of safety controls for the machine. First is the manual e-stop. Anytime the machine is using PID controls, you can press it to interrupt it immediately and stop any further movement. The other uses a time of flight sensor to measure the position of the platform and make sure it's not getting too close or too far away and collide with itself. If it detects it, it also automatically stops the movement and you have to manually lower or raise the machine to a safe height. So, as you have seen, this setup is incredibly accurate, with the error being usually around 1/1000th of an inch. However, sometimes you want to move the platform just a little bit in either direction. So I've included a rotary encoder that you can twist to move the platform up or down by 2/1000ths of an inch. So the final piece of the puzzle is to put it all on rails so that we can alter any piece of wood that will fit on our workbench. We can move it back and forth and along the whole length of the workbench. You can even include stops along the rails to make sure you don't accidentally overextend, or to limit your movement in any direction and create perfectly straight lines. Now, let's see how accurate our machine is by testing it out on a piece of wood. Alright, let's look at the results. So initially, we started with a piece of wood that was just like this. A whole bunch of ridges, not suitable at all for woodworking. Then, we ran the machine. First, it started out by running this bit here over this face and getting it to a uniform thickness. This made it nice and flat and ready to accept some grooves. Then, we did a whole bunch of different grooves of different depths to test the accuracy of our machine. As you can see, each of these gauge blocks line up perfectly with the depths of their groove.